This is part 3 of section 6.5, polar graphs. In this section, we're going to start with another family of graphs, which is Rose curves. We're going to graph a couple, and then we're going to talk about their characteristics that make them a family. And then we're going to finish up the unit, this section, with 2 other common graphs. So just as a quick review, let's look at our symmetry tests so that we can talk about how we're going to graph these. So we have 3 common symmetry tests that we use when graphing polar graphs. One is with respect to the polar axis, which is the x-axis. You can replace theta with negative theta, and if they're equal, then it has that type of symmetry. Another thing you can do is replace theta with theta minus pi. And that will do the same thing as replacing theta with negative theta. It'll put us in the other side of the quadrant. So if you think about it, where you would be, and the idea is that the negative of that would be the same. So in other words, because we're going to use this idea in this section, because Rose curves are a little strange. I don't know why I just did that. If we take a point that is pi minus theta, that would be right around here. And then if we take negative r, that would send us over here. So we'd be at the same point. Okay, the next type of symmetry is with respect to the line theta equals pi over 2, which we would commonly call the y-axis. So in that case, we will be replacing theta with pi minus theta. That'll give us the point right here that's marked. Or what we could do is do negative theta, which would be here, and negative r. So they would be the same as well. So you get these 2 points again. And then finally, the last one is with respect to the pole. So we can do either the negative of it, so that'll take r from one side to the other, or if you just take theta and add pi, so if you're here and you add pi, if you're here and you add pi around to the other side, you would be over here anyway. All right, so those are our symmetry tests. So let's try it out on a Rose curve. So starting with symmetry, so let's check for symmetry. And I'm not going to go into as much detail as I did in the beginning, because you guys now see what we're doing here, and you can double check the symmetry test. So we're looking for polar axis symmetry. And so I am just going to go right to replacing, because I know this is a different test, the Rose test, negative r on one side, and I'm going to use pi minus theta in the other side. A lot of times what you can do with these is, and I'll show it up here for this one, you can try the most common test. So if I put r equals 2 sine would be negative 2 theta. From what we've done, we know that sine is odd, and you can kind of do this in your head, and you can see that that's not going to work out, that I'll have to pull the negative out. So I'll have a negative 2 sine 2 theta. And so, especially the Rose curves, when I think about this, the way they look, you'll see in a minute why I say that, because they do have other symmetry. Some of them are symmetrical over the line pi over 4. So that's why these tests are a little tricky for the Rose curves. So you should go ahead and try the alternate. So this is a no, so I'll go back and try this one. But if you start to understand that you're better going right with the second test, you're better off. Okay, so if I expand this using my subtraction identity, this is going to be 2 times, and it will be sine 2 pi, I'm distributing that 2 inside, and then cosine 2 pi minus cosine 2 pi sine 2 theta. Okay, so the first term goes to 0, so I'm left with negative r equals, and I have a negative, this will be positive 1 here, this is 1, so I have a negative here, so I get negative 2 sine 2 theta. So these can go away, the minus signs, so this is a yes. So we do have polar axis symmetry. The next one we're going to test is theta equals pi over 2. And again, I'm going to go right for the alternate test. So I'm going to put in that negative r is going to equal 2 times sine of negative 2 theta, and so I get negative r, again sine is odd, negative 2 sine 2 theta, and of course that is a yes as well. And then finally, for my third test, I am going to put in the pi plus theta, which this test is for the pole. So I'm going to put in that r equals 2 sine, and then I'm going to put bracket here, 2 times pi plus theta, and I get 2 and then sine of 2 pi cosine 2 theta plus cosine 2 pi sine 2 theta. And hopefully you guys can see the same thing here. This cancels. I'm just left, this goes to 1. So I am just left with this term and this, and that's equal to r. So this is also a yes. So this curve has all 3 symmetries. So we're going to draw half of it again and then go back and draw the rest. This is r. Move this up just a tad because I want to write the equation underneath here. So r equals 2 sine 2 theta, and I'm going to go from where I have a possibility of negative sign and positive sign. So I'm going to start at the bottom of my circle here, negative pi over 2, and I'm going to go around to pi over 2. So that way I can see if any of my values are positive or negative. Okay, so we have negative pi over 2, negative pi over 3, negative pi over 6, and we have 0, and we have pi over 6, pi over 3, and then pi over 2. Okay, then substituting in negative pi over 2 multiplied by 2 will give us a negative pi, so sine of pi is 0, so this is 0. Negative pi over 3, the sign will be negative, so I'll have negative 1.7 when I substitute that in. The next one is going to give me negative pi over 6, so it's going to be 2 times sine of pi over 3, which is going to be negative 1. And then at 0, I'm at 0 again, and then pi over 6, I'm going to be 2 times a half, which is 1. Pi over 3, I get 1.7. I'm just going to get the opposite of all those. Okay, so here is how this looks. Now what you want to remember is that when I'm at negative pi over 3 here, I'd be around here, but it's negative, so I have to go to that side. All right, so let's start graphing. You'll see how this works. So at negative pi over 2, I'm at 0, and then at negative pi over 3, as I said, I would be over here, but the r is negative, so I would be around here. And then at negative pi over 6, I'm at 1, so taking that to the other side, it's here. And then I'm back at 0, and then from there I'm back at 1. And then I'm at 1.7, and then I'm back at 0. So it looks like this. So we start here, we go up to here, come back to there, and then from here we go here, go up to there, and back. So reflecting all those points, then we are going to have a point here, we're going to have one here, we're going to have one here, and here. So drawing the other side, we make a flower. So that's why this is called a rose curve, because it looks like a flower. And if you want, notice it has 4 petals. I'm going to talk more about how we figure out how many petals it has in a minute. Okay, let's do another one. Do another sine one, but this time the two numbers a and b aren't equal in this one. So we have r equals 2 sine 3 theta. Now in this one, our symmetries are going to be different because this curve does look different. So I'm going to quickly run through those, and you can verify them on your own. So we have polar axis symmetry, and that is going to be r equals 2 sine negative 3 theta, and the answer for this is no, and it's no even if I use the other method with the pi minus theta. It's still no. And the second one is going to be the line theta equals pi over 2. And I'm going to put negative r equals 2 times sine. That's supposed to be a 2. It looks like a theta the way I wrote it. 2 times sine of negative 3 theta. And so you're going to have negative r equals negative 2 sine 3 theta. So this is a yes. And then finally you have at the pole. And for that one, you're going to have a no as well. So this one is also a no. So you can go through those on your own. So we have line symmetry. So we're going to use negative pi over 2, negative pi over 3, negative pi over 6. I'm going to use 0, pi over 6, pi over 3, and then pi over 2. And then I'm just going to quickly put the values in for this so you guys can see them. You can double check me. All right, so at negative pi over 2, we're at 2. So that's there. And then at negative pi over 3, we're back at 0. And then at pi over 6, we're at negative 2. So we have to go over here to this side. And then we're back to 0. And then at pi over 6, we're at 2. And then at pi over 3, we're back to 0. And then pi over 2, we are at, whoops, I forgot the negative. We're back here. Okay, so this looks like this. So we start at the bottom. We're traveling in the positive direction up to 0. And then we come over here. We go back to 0. And then we come out here. And then back to 0. And the only part we're missing is this part. So we have 3 petals. So this is a rose curve with 3 petals. Okay, I don't know if you guys figured out how the petals work yet. So the next thing we're going to talk about is the symmetry of the rose curves, a summary of them, whether they're cosine or sine. I told you 2 sine ones, so we're going to see how they would look with cosine as well. Okay, but I'm going to do that in our last video because this one is already running long.